everyone, and welcome to the Cloud Lunch and Learn sessions. My name is Hugo Barona, and today we have Michael Levan with us talking about Azure Kubernetes Service and Azure Container Instance. I hand over to you, Michael.
Hey everybody, how's it going? Thank you so much for joining. My name is Michael Levan. I run a tech company called CloudDev.Engineering, and essentially what we do is 50% consulting and 50% training, things like these cloud lunch and learns, uh, you know, blogs, videos, and all of the other types of trainings out there. The other thing that I do right now is I'm a full-time trainer at CBT Nuggets. Is essentially brought on to beef up the Azure and DevOps training that's available on CBT Nuggets. We have a cool professional DevOps course going on right now, which is really great. And that's pretty much where I'm at right now. Prior to that, I was a lead DevOps engineer. I was leading a team in the US for a global organization. And after that, I pretty much decided to go out on my own and, be able to do cool stuff like this. So pretty much what we're going to be talking about today is the ability to have EKS, AKS, which is Azure Kubernetes Services, tied into Azure Container Instances. And essentially, what Azure Container Instances are is they give you the ability to run containers like you would locally, like a Docker container, for example, or any other type of containerization engine, except instead of running it locally, you just run it in the cloud. So before we kind of jump into the technical aspect of the demo, I just wanted to take 5 minutes to kind of go over what containerization is and what orchestration is at a high level if you're not aware of it. So essentially, containerization gives us the ability to deploy an application without having to deploy an entire virtual machine. So, if you remember 10 years ago or so, maybe, 7 years ago, there were a big demand for a ton of virtualization. And that was because we, wanted to move a little bit off of bare metal. We wanted to get into virtualization. And that really helped us with building a smaller footprint. But at that point, we still needed something a little bit smaller. We needed something to key in and hone in onto like, hey, we just want to run this application. We're developers. We don't want to worry about infrastructure at the moment. Even though, we need infrastructure for a lot of things, we just want to be able to run an application, even if it's just for testing purposes. So really what containerization gives us is to easily deploy applications. It gives us that smaller footprint for any type of deployments. There's no need to run a virtual machine. Let's say you want to test a piece of your C# backend code, maybe like some PayPal integration, for example, and you want to test just that key feature. Well, now you don't have to worry about spinning up a virtual machine for that anymore. Really, at this point, all you have to do is just spin up a Docker container, test the code, make sure that everything works, and then you're good to go. And then another big thing at this point, honestly, is the community support. Like there is just so much, as we all know, in 2018 to now. I mean, containerization has just really lifted off, in my opinion. It's always been large, but I feel like the past few years, it's been getting really, really crazy. So, there's a ton of community support right now, and it's really, really awesome. It's a beautiful thing that we all get together and work together on these types of things. So I did put a few little images here. I'm sure we all have seen or have heard of the Docker whale. A few other things that I wanted to put in here, which you may not be aware of, is Container D, which is essentially the or not the orchestration, but the container engine that's running in the back end. And then this is an image of LXC. So LXC containers have been running on Linux for, I don't know, over 10 years. And, that's really where like containerization got started, I would say. I think there were other variants of it prior, but I think LXC was, more or less the bigger picture of it when containerization really started to occur. So then we move on to orchestration, and I wanted to split these slides up because I feel like I do see a lot of people and organizations putting containerization and orchestration together. Like if you look at a job post, they'll be like, hey, containerization platforms using Kubernetes and Docker. But that's not really the case. It's very much separate. So your Containerization is to run a container, just one container, and your orchestration is the ability to scale out those containers. It's really just a management platform for your containers. And it's very, very much two different pieces of technologies. So with your orchestration, you can manage containers at scale. You can provide a central location to manage these containers. There's different features like self-healing. So if a container exits, it goes down, it'll automatically get spun back up depending on what type of orchestration platform you're running. And then the ability to create services and make those services public facing. And then we have two icons on the right. We have the Kubernetes logo and we have the Docker Swarm logo. I would say Kubernetes is probably like the victor right now. Docker Swarm is still very much used, but I would say, Kubernetes is probably the biggest one right now, and Docker Swarm and Kubernetes are probably the top two at the moment. So where does Azure come into play with this? If you've been, taking a look at Microsoft news, if you joined Microsoft Build this year, you'll notice that they're putting a lot of effort into containerization and orchestration, because right now it's very much the future, for however long that's going to be until the next thing comes up. But really, right now, containerization in Docker and orchestration with Kubernetes is the big thing, and Microsoft's really, really honing in on this. So where do they kind of come into play? Well, the first thing is Azure Kubernetes Services. So really what AKS gives you the ability to do is not worry about managing the master node. And if you're not aware of the master node is essentially the API. It's where like the version of Kubernetes is running. It's the API, 1.15.6, for example, and that's really what's like managing all of the features that you get out of Kubernetes. And then the worker nodes are just where the containers and where the deployments are living. So with that, they kind of take off that layer for you. It makes it a little bit less cumbersome to manage because, again, as developers, we want to deploy applications. And sure, there are always going to be instances where we have to manage infrastructure, but services like AKS kind of lift that off for us so we can just worry about everything at the application level. And then we get into Azure Container Instances. So Azure Container Instances, like I said before, they're really just a way to run containers like we would locally. Like if we do a Docker run on our command line, and then we run like an Nginx container or something, for example, like it's just going to give us the ability to do that, except do it in the cloud, which of course can make it a little bit better, like especially in a team aspect, right? Like if I'm testing a container locally, it's really not going to do anybody on my team any good unless I push that Docker image up somewhere to Docker Hub or to Azure Container Registry. But still, really at that point, like it's going to help more if that container is running in the cloud for us, and that's really where like containerization is going to come into play in the Docker, or I'm sorry, in the Azure space. So these are really the two key features. Now, the demo today is about how to use these key features, but use them together. So this is something called bursting. So you burst deployments, containers in AKS to ACI. And the reason why you want to do that, at least in my opinion, is because the more you scale out containers, the more worker nodes you're going to need. And those worker nodes are just virtual machines running. And obviously that can get expensive. And you can end up having a ton of worker nodes that you have to manage, which again brings us back to the issue of like, hey, now you have 10 virtual machines that you have to manage. Who's managing that for you? Security updates, any type of patching, any type of zero-day vulnerabilities, updates, anything like you'll have to worry about managing all of that. And plus there's a cost, right? Like nobody wants to pay for 10 virtual machines to run containers. We want to use containers to get away from virtual machines. So that's really the reason why you're going to want to use bursting from AKS to ACI. So what I did was I kind of just demoed this over the weekend, And what I did was I put together this list of things that I needed to do to get this up and running. So what I'm going to do is I'm going to literally follow this to the T, and then I'm going to share this out with Hugo, and he'll be able to share it out with everybody, just to, get an understanding of what it looks like. And so you can do it yourself. And you can do different iterations of this if you want. This will just give you like the key aspects of what it's going to look like to get this all up and running. So with that, let's just go ahead and take a look at the demo. So I already have an AKS cluster here, because it could take like 20 minutes to set up, and obviously we don't want to sit here and twiddle our thumbs. But what I do want to do is show everybody the two key ways that you can set up bursting, because when you set up an AKS cluster, you have to specify that you want to burst into ACI. So I'm going to go to the Azure portal here, and there's going to be two different ways that we can do this. First, if we just want to use the UI, we just type in AKS and we go to Kubernetes services and we add a Kubernetes cluster. So here, and again, I'm not going to create a new one. I'm just going to just show everybody where the option is kind of, and then we'll click next. And here's where the option is. So excuse me, by default, this is disabled. So if you want to create a Kubernetes cluster with ACI bursting, you have to enable it here. And then once you enable it here, what'll happen is, and we'll be able to see this, we're going to see a worker node specifically for ACI bursting, and it'll automatically deploy that for us. Now, the second way to do it is...
Michael, just one
Yep.
sec. Frederick is saying here that he can't see your screen, but yeah, I believe it's fine for other people. Can you please confirm on the channel, on the chat, that it's fine for you? Can you see the screen?
Fine here.
Okay. So sorry, you can continue, Michael. Then.
Okay, cool. Yeah, sure thing. Yeah, and again, if you're having issues with the video or that you can't see the screen, the whole demo, I have everything written down, the steps that I'm going to take, and we'll be able to share that out for you if you're having any issues. That'll definitely be another option. So the second option to creating a AKS cluster with ACI is by using the AZ command line. So if you're not aware of the AZ command line, it's just the Azure command line interface. It's just a CLI that you can use to interact with Azure resources. And what you can use is you can use this command here, and this is going to install the connector, the ACI connector. And then you're going to specify your resource group. You're going to specify the name of the cluster, and then you're going to specify the connector name, which is, it's just like a metadata name. You can really name it whatever you want. That doesn't matter. Just make sure you specify where you want it to be, preferably in the same resource group as the AKS cluster, and then the name of the AKS cluster here. But this is going to be the command that you're going to want to use. So what I need to do at this point, once I have my AKS cluster up and running, which I do, is I need to run the AZ AKS get credentials. And what this is going to do is this is going to pull down the Kubernetes configuration onto my local host so I can interact with Kubernetes from my computer. Every Kubernetes cluster is going to have something called a kube config, and the kube config is one, metadata of what your infrastructure looks like, and two, gives you the ability to interact with that Kubernetes cluster. So I'm going to literally copy this, open up PowerShell core, paste this in, and I'm going to put in my information here for my AKS cluster. It's Cloud Family AKS 01, Cloud Family AKS 01, and we'll check that resource group. It's in AZ204. Go back here, AZ204, and then we'll click enter here. And then what this is going to do is this is going to automatically bring down our AKS cluster. And not only that, but it's going to set it as the current context. So in a kube config, if you're managing like 10, 12, 15 different Kubernetes clusters, or even like local Kubernetes clusters with Minikube, this will essentially take the current one in AKS and it's going to make it as your current context, which means that's going to be the Kubernetes cluster that you're going to be interacting with, but you can also switch between different Kubernetes clusters if you want to. So I'm just going to make sure that my Kubernetes cluster is up and running, and it is, we are connected. And as you can see, remember how I said that once we selected that bursting option for ACI when we're creating our AKS cluster, this is the virtual node that's created for us. So this is just going to work as a virtual, as a worker node essentially, but instead of having multiple worker nodes in our Kubernetes cluster, we're just going to have this virtual node here for us, and it's going to start bursting out into ACI versus keeping those deployments locally essentially in the Kubernetes cluster in the worker nodes. So I'm going to go back here, and we're just going to go ahead and scroll down. As we can see, we already did this. We were able to get our nodes. This, of course, looks different because I'm on a Windows machine right now, and I was testing this on my MacBook. So the next thing that we're going to have to do is we're going to have to bring down some sort of application for the bursting. So if we want to actually see this in action, we need to be running something on our Kubernetes cluster. And to do that, well, we're just going to run an Nginx ingress application. Essentially what it is it's just an ingress I guess deployment or container. It can be multiple containers for any type of front-end application. So I'm just going to go ahead and I'm going to copy this. And if you're not familiar with Helm, essentially what Helm is a package manager for Kubernetes. So there's two things that you can do with Helm. One, you can bring down pre-existing environments. So like right now, for example, I'm bringing down a environment called Nginx Ingress. So this is just an environment that's sitting in Helm that somebody built or Nginx built, and we can use it. Kind of like if you use like a Docker image from Docker Hub or something like that. The second thing that you can do with Helm is you can have Helm charts. So you can set up your application from Kubernetes manifests, but use them as charts. And that it gives you the ability to like have variables in there in like a Jinja 2 type of syntax. The best way that I can explain it is if anybody on the call is familiar with Helm, it's kind of like Helm Galaxy, or I'm sorry, Ansible. It's kind of like Ansible Galaxy, the way the charts are initialized like that. So what I'm going to do is I'm going to set this up in my kube system namespace, and I'm going to run a Helm install here. And then what this is going to do is this is going to bring down our application for us, and this is what the application is going to look like. So here's the API version, the kind, all of the metadata, and then what the containers are going to look like in terms of ports, backends, if there's secrets involved in the containers, things like that. So let's go ahead and go back here. And then after that, we can run our kubectl get services, which is going to show the different services that are running in the Kubernetes cluster. And that's going to bring back our Nginx ingress for us. Let's go back here. We'll paste this in. And then, I'm sorry, I know the terminal is a little bit big. I just wanted to make sure that it was the proper size if anybody was on mobile. But as we can see in this little bit of a mess, there's our Ingress Nginx controller, and then the default backend for Ingress Nginx. So that's currently running, and it's running as one service right now. So what about if we want to scale that out? Well, that's where, the ACI portion comes into play. So what we're going to do is we're going to run this. We're going to run kubectl. We're going to scale the deploy. We're going to scale the ingress controller, not the backend. And then we're going to make 10 replicas, for example, and that's going to be in our namespace kube system. Okay, so I will copy that, go back to my terminal. Let's go ahead and clear the screen here. Bring this in. We'll run this. Okay, and now our Ingress Nginx controller is scaled, and just like that, it's scaled. Like it's pretty quick. It's relatively straightforward. It happens in a matter of seconds. So I'm going to do kubectl get deployments, namespace, kube system. Okay, and as you can see, here's the Nginx controller, and it's currently at 4 of 10. It's spinning up right now. What this means is there's currently 4 active out of 10, and it'll, of course, take a little bit to spin up, and there it is. There's our 10 out of 10 here, and that's our way of essentially scaling out into ACI. Now, let's go back to the portal, and I'm going to go here. Go back to our AKS cluster. And let's go down to insights. Let's close this out. Okay, so here is our application insights for our AKS cluster. And then we're going to go to containers. Scroll down. Okay, and here's our Nginx controller. Here's our container name, our container ID, what the status is, where the image came from, different timestamps and stuff like that. We can also see if any deployments are in action right now. Here's our controller. We can see our Nginx controller with 10 out of 10 here, and we can see that this is stable and successful and healthy. Speaking of health, we can view the health preview here. We can see that our infrastructure is good to go. And let's go back to containers. Scroll down here, we can see that our Nginx ingress controller container is good to go. And that's it. That's how you essentially scale out your deployments or your containers inside of ACI instead of using Kubernetes workers. So go back here to the PowerPoint and I will take any questions.
Okay, Michael, I think we have here a few questions. So it looks like Richard is asking if you create an AKS cluster without enabling virtual nodes, can you enable it after a cluster creation, or is a new cluster needed?
Yes, you can. So let's go back here. Sorry, this command here, this will do it for you. So if you create an AKS cluster and you don't enable ACI bursting, if you use this command, you'll be able to add it at any time.
So you can afterwards install the connector for ACI and that's it.
Correct.
Right?
Yeah. As long as you run that command, you'll be good to go.
Yeah. Well, I don't know if anyone else has any questions. I think pretty much the... So we have here another person asking, can you show us where in the YAML file you indicate that your deployment should be scheduled into an ACI instead of in any VM on the node pool?
Oh yeah, so that actually happens by default as long as you set up your Kubernetes cluster with the worker nodes, because if I go back to kubectl get nodes, as you can see here, I'm not like specifying, like I have a VMSS here for virtual machine scale sets, but the only worker node that I actually have running right now is my virtual node ACI Linux, which is the cloud bursting. So it's going to automatically always go to that node. Now, if you have multiple worker nodes in your Kubernetes cluster, essentially, I would say probably the most straightforward way to set it up would be to have your Kubernetes manifests inside of the labels, specifying what worker node you want it to go to in your labels.
Okay, we have one more question. So would it be possible to add the ACI instance to a specific VNet on bursting?
A specific VNet on bursting. I actually don't know the answer to that question, but I will get that answer to Hugo after this, and he should be able to get it over to you. I just don't know that off the top of my head, to be honest.
Okay, and just in relation to these slides, I just want to say some things. So in case you did not have a chance to do it in the beginning of the session, I would like to share with you this opportunity provided by Microsoft to access free relevant materials related to this session. So in order to access these materials, you can scan the QR codes or access the aka.ms link in this slide and fill in a quick form. It is also important for us that you do the registration, so you'll be officially registered in this session, and it's a way to justify the efforts from collaborators and ourselves to keep this initiative. So please take a minute and register to the form. I think it's coming something in the channel as well. So, okay, yeah, it's only just comments. So I think no more questions. I actually have one question in the meantime. I have one question for you. So as far as I understood, you are basically using your you are using your ACI instance to allocate your containers so you can scale the containers to your ACI instance, right?
Sort of. So essentially what you're doing is, let's say you don't want to have to worry about like managing multiple worker nodes. You don't want to have that overhead. What you do is when you deploy those containers, like let's say you're doing a Kubernetes deployment or a Kubernetes service, anything in that aspect, what you're doing in that case is you're essentially telling AKS, hey, instead of storing this locally for me on the, just on a worker node, burst it out into ACI instead.
Yeah. But in this case, you are using the resource of the ACI, right?
Yes. Yeah.
And
Yeah.
my question is, imagine a scenario that you want to scale massively and you realize that the ACI instance is not able to host all the containers. So what would you do? Create another ACI instance?
Well, the ability with the ACI worker node, well, that's not a worker node, but the instance in itself running in Kubernetes, it's going to auto scale for you based on how many replicas you're deploying.
Okay, perfect. All right. Okay, so I think we have no more questions on the channel, so I think we are done, right?
Cool.
Okay, thank you everyone to attending this session today and joining us. I hope you enjoyed the session, and next week we will have another Cloud Lunch and Learn session, and have a nice day.
Thank you. Take care.
Thank you, Michael. Thank you.